Hello everybody. Today I am going to discuss about this kind of general equation of second degree, and we want to find out necessary and sufficient condition under which this kind of second general equation of second degree will represent a pair of straight line. Okay, necessary as well as sufficient. Necessary condition means that if we assume that this equation, this general equation of second degree represents a pair of straight line, in that case we are going to prove a condition. And what is the condition? Condition is that that this kind of expression, that is actually the expression of the your so-called determinant delta. So this determinant delta, this is actually the determinant delta, the so-called determinant delta, this delta. Okay, and we are going to show that if we assume that the general equation of second degree represents a pair of straight line, in that case delta would be is equal to 0. And what is the meaning of sufficient condition? Sufficient condition means that the opposite part. That means if we assume that A, B, C, this all expression, this delta becomes is equal to 0, then we are going to prove that this kind of general equation of second degree represents a pair of straight line. Okay. So this is called the necessary and sufficient condition. Be very careful about these two special kind of conditions, because throughout your course of mathematics you will deal this kind of conditions. Necessary condition, necessary means if certain result is true, then such and such results, that like delta is equal to 0 should be true. And sufficient part means the opposite category of result. That means if the second result is true, then the first result should also be true. Sometimes we call it if and only if condition. It means that if the first condition is true, then the second condition should be true, and only if portion means the sufficient part. That means only if the second condition is true, then the first condition should also be true. So there are two very important terminology. One is this is called necessary and sufficient condition. And the second one is called if and only if. In shortcut we write this if and only if in this way, I double F. So these are standard notations that is used throughout the mathematics and in different branches of science as well. Okay, so in future whenever you get this kind of result, if and only or necessary and sufficient condition, it means that you will have to prove both sides, from the first to second condition and from second to first condition. Okay, so over here I am firstly going to show, assuming that this kind of second degree equation represents a pair of straight line. This is our assumption, and we are going to show that delta should be is equal to 0. Okay, but my proof would be a bit different from this proof, because I feel that my proof is much more comfortable. That's my personal opinion. I'm not imposing anything on you. So if you feel that the technique shown over here is easy to you, you can prove this technique, the result through this technique. However, the converse portion is not properly given over here. So regarding the converse part, I feel that the treatment written in this result, that is actually the treatment that is discussed in the book of R.M. Khan. And already this file has been given in your Google Classroom under this classwork section. under this pair of straight line, this title. So you will get the PDF file from this link. So I have my own copy, so I am starting the proof now. So we assume that this is the this is the equation. So let me draw the picture. Let us suppose that this represents a pair of straight line. So if it is a pair of straight line, in that case, we don't know what would be the point of intersection. Hopefully, as because this is the non-homogeneous part. Okay, if there is no non-homogeneous part, if it is perfectly homogeneous, in that case we prove that the equation that the pair of straight lines pass through the origin. But now because of the fact that this is a homogeneous equation of second degree, therefore we can say that the straight lines are not passing through the origin. Hopefully the straight line should look like this. This may be one straight line and this may be another straight line. So this is the point of intersection. Okay, and what would be the point of intersection? Let us suppose that the coordinates of the point of intersections are alpha comma beta. Okay, we suppose that alpha comma beta is the coordinate of the point of intersection. Now, through this point of intersection, let us draw one more parallel coordinate axis. So these are x-axis and this is our y-axis, and these are new set of axes, probably capital X and capital Y. I have used the yes, capital X and capital Y. So we can say that these new axes are the capital X axis and capital Y axis. Okay, now we make a transformation like this: capital X is equal to x minus alpha, capital Y is equal to y minus beta. That is actually the traditional, in the traditional sense we call it the translation formula. Okay, so we make a translation and shift the origin to this point of intersection alpha comma beta. So if capital X is written in this way, x minus alpha, so small x would be written in this form, capital X plus alpha, and small y is equal to capital Y plus beta. Now we apply these two results, equation number 2, the result represented by equation number 2, we apply the result represented by equation number 2 in this equation number 1. Got it? So the total expression will be converted in terms of capital X and capital Y. So this is the expression after putting small x is equal to x plus alpha and small y is equal to y plus beta. And if we expand them, I am not going to show the expansion because this is actually the mathematical very easy mathematical manipulations. So I am leaving these manipulations for you. Okay, so we will ultimately have this kind of expression. I am making them in writing them in a group because it is very similar to the expression used in equation number 1. Just in place of small x and small y, we have put capital X and capital Y, including the constant c. And this second term is very similar to the equation except the equation number 1, except the constant term c. Over here in place of x and y we have alpha and beta, and the rest of the terms are written over here. This is the rest remaining terms after the expansion of this expression. Okay, hopefully this much is okay for you. Now we arrange them in this fashion. You see, this purely second degree term in capital X and capital Y. We have written them in this way. We are keeping them separate. Now we extract the coefficient of x, capital X from this and capital X from these two terms. In that case, we have this much, this is the coefficient of capital X. Similarly, we have the coefficient of capital Y, and the remaining portion, that is actually the quantity without any capital X and capital Y. We can say that this is now the constant term under consideration. So this is the expression, the total expansion of equation number 1. And this is an expression or an equation involving the new coordinates capital X and capital Y. And now forget about this small x and small y. Okay, now try to concentrate on this capital X and capital Y. Over here in terms of capital X and capital Y, you observe that these two straight lines are passing through the new origin. Got it? These two straight lines are passing through the new origin. Let us call it the origin maybe O prime. Okay, and so we can say over here that with respect to the new coordinates, this pair of straight lines represented by equation number 3, of course. This pair of straight lines are passing through the origin. Therefore, with respect to the new coordinates, they should be purely homogeneous equation of second degree in terms of capital X and capital Y, because we know that a purely homogeneous equation of second degree always represents a pair of straight line passing through this origin. So forget about this capital Y and capital X. Okay, forget about these two coordinates. Now with respect to these new coordinates, we find that this equation number 3 must be a homogeneous equation of second degree in terms of capital X and capital Y. And what does it mean? It means that the coefficient of X should vanish, the coefficient of Y should vanish, and this constant term should also vanish. Is it clear to you? ব্যাপারটা বোঝা গেল তোমাদের কাছে? কারো কোনো জায়গায় কোনো সমস্যা আছে? Is it clear?
Yes, sir.
So now we can say that these three quantities, the coefficient of X, coefficient of Y, and this constant term should be equal to 0. And therefore these are the results. You see this coefficient, forget about these two, this should be is equal to 0. So A alpha plus H beta plus G, that is equal to 0. So this is the result, equal to 0. Similarly the second term, the coefficient of Y should be 0. It gives H alpha plus B beta plus F, and this is the constant term. These three expressions should be is equal to 0 individually. They should be equal to 0. Now consider this last expression, equation number 6. The expression given by equation number 6. What do we have? We are multiplying this equation number 4 by alpha. Okay, and we are multiplying equation number 5 by beta, and then subtract the multiplied quantities from equation number 6. So what we observe? We get this kind of result. This is the equation number 6, and this part is actually alpha times equation number 4, and the remaining part is the beta times of equation number 5. So we got this result, and you would observe that this A alpha square would get cancelled. This B beta square would get cancelled. This H alpha with this negative sign and this H alpha beta with this negative sign will cancel with this twice H alpha beta. So remaining portion is that twice G alpha plus twice A beta plus, sorry, not twice G alpha, sorry, I made mistake. This twice G alpha minus this twice G alpha, they would construct this single G alpha. Similarly, twice A beta minus this twice A beta, they would construct this A beta. Okay, and this constant C we will again construct this constant c. Okay, so over here we have this kind of result. This is the third result we have. These are the two results involving the variables alpha and beta, and this is one more result involving the variables alpha and beta. So let me clear the screen. Okay, fine. Now from 4, 5 and 7, if we try to compute the variables of these unknown quantities alpha and beta, you will get certain expression of alpha and beta. And after computing the expressions of alpha and beta, if you put them in the equation number 7, then ultimately you will find that you get this determinant delta. What is this determinant? This determinant is actually the this A H G. So this, they would construct the first row A H G. Got it? Then the second row H, then B, then this F. They would construct the second row H B F. Okay, and the third row is G, this F, this C. They would construct this third row G, F and C. So in brief, what we say, we are computing, if we are trying to compute the values of alpha and beta, and after that we are putting the values of alpha and beta in this equation. So that means we are actually eliminating the quantities alpha and beta. Okay, and always remember that if we want to eliminate two unknown quantities, we always need three equations. Over here, two unknown quantities are alpha and beta, and the three equations are 4, 5 and 7. So if we eliminate these two quantities from these three equations, then we will get this determinant delta. This is actually a standard result of determinant and matrix. So I am not going in the detail, and you don't need to show all the detail. You can directly say in exam that we are just eliminating alpha and beta, and we ultimately get this result delta is equal to 0. As because it is a standard result, you don't need any proper computation for this result as well. Okay, so after writing 5, you can directly say that eliminating alpha beta, we get this result delta is equal to 0. Okay, so this is the first part. It proves that if equation number 1 represents a pair of straight lines, then we must have delta is equal to 0. And now the converse portion. Let us consider the converse part. That means the opposite proof. So we will have to assume that equation number 8 is true. That's why we assumed or we suppose that the relation number 8 is true. And under this supposition or under this assumption, we have to prove there is a printing mistake. Then we con this, it should not be con, we can always find the following three linear equations. Okay, that is actually the result of a linear algebra. Let me show you how can we find this result. I don't know whether you have any knowledge regarding this. Hopefully you must have certain knowledge, because linear equations have been discussed in 11 and 12 as per the syllabus, so far I know. What I am trying to say is that suppose we have three unknown quantities, say and x, maybe y, okay, and maybe this z. So just this is a result of linear algebra. I am just trying to show the result in brief. I am not going to prove the entire result. Suppose three quantities are there, x, y, z, and involving three quantities we have three equations. And the question is that whether do we have any solution to this equation or not. Answer is yes. These three equations are three linear equations involving three unknown quantities x, y, and z with the right hand side equal to 0. Okay, and this kind of equations are called homogeneous linear equations. You will discuss or you will study all these kind of results, homogeneous linear equations, in your algebra portion, probably in the next paper or your subsequent papers. That is called the linear algebra particularly. Hmm. Anyway, so over here the question is that whether do you have any solution to this equation. Answer is yes, we have minimum one solution to this equation. And what is the solution? The solution is that x is equal to 0, y is equal to 0, and z is equal to 0. This is a solution. If you put x, y, and z equal to 0, 0, and 0, in that case, of course, these three equations are going to be satisfied. Hmm? But it has a speciality, this equation has a speciality that this equation has some, it may have, not always, it may have some non-zero solution as well. Okay, non-zero means there may be certain non-zero values of x, y, and z satisfying these three equations. And what is the condition under which these three equations become has a non-zero solution? The condition is that this determinant delta should be equal to 0. This is the determinant of the coefficient matrix. Okay, and the result says that if the determinant of the coefficient matrix becomes is equal to 0, then this equation has a non-zero, minimum one non-zero solution. It may have more than one solutions. I have shown an example in my previous class that if we have more variables and less equations, then you may have infinite number of solutions. In this case, depending upon different situations, we may have more than one solution. We may have infinite number of solutions as well. Anyway, I am leaving the discussion for your linear algebra course. What we can extract from this information is that if we divide these three equations by z, okay, suppose we are dividing this equation by z, in that case what we have, we can write this equation in this fashion. I am trying to convert this equation in the form we have currently. And this should be x by z, then this is also y by z, and no z will be present over here. Now, if we suppose that x by z is equal to, suppose this x by z is equal to p. If we suppose that x by z is equal to p and y by z, and this y by z is equal to q, okay, in that case we will be able to write this expression in the form p, q, and all. This is P, this is P, this is Q, this is Q. Okay, so we actually have a result, and as because we are able, if delta is equal to 0, we can find non-zero values of x and y and z, and therefore we can always find some values of p and q. Got it? That's why we can say that if delta is equal to 0, then we can find p and q satisfying these three equations, and that is written as a single line over here. Then we can always find the following three linear equations with two unknown p and q as satisfying these three equations. Got it? Is it clear to you? তোমাদের কাছে ব্যাপারটা ক্লিয়ার হলো? বাকিটুকু ম্যাথমেটিক্যাল কম্পিউটেশন। Is it clear?
Yes, sir.
So remaining portion is just mathematical computation and a little bit of geometric idea. That's all. So we can say that yes, we have two unknown quantities p and q satisfying these three equations, and now we again apply a translation. Capital X is equal to x minus p and capital Y is equal to y minus p, so that this x and y can be written in this fashion. Just similar to this result. The idea was that our again we have a similar kind of expression, just in place of xy we have p and q, that's all. Hmm. And now sorry, just in place of alpha and beta we have p and q, that's all. So let me write them p and q over here in place of alpha and beta. So this is our p, small p. And this is our small q. Just I am using a little different notation because already alpha beta has been used in our first part. Okay. Now our target is to again we are trying to make same kind of manipulations, geometrically same kind of transformation. So our target is to transform this from small x and small y axis into capital X and capital Y axis, and we want to show that this expression in terms of capital X and capital Y would be a purely second degree homogeneous equation, so that we can conclude that the given equation represents a pair of straight lines. Okay, suppose we don't know whether this given equation represents any pair of straight line or not. We don't have any such information. So we can't write any geometric figure that I that I have drawn over here. But still, without that knowledge, I am trying to show that this given equation number 1 represents actually nothing but a pair of straight line. So how can we show this result? We are again applying this transformation formula to equation number 1. But before that, let us prepare them in this fashion. You see, if we apply this equation number 12 in equation number 1, then we would again have similar result like we got in this line. So that is actually the purely second degree homogeneous expression, and similar to the previous one, we got the coefficient of x, we got the coefficient of y, and the remaining portion would be the constant term, and over here in place of alpha beta we actually have small p and small q. Got it? But due to these three equations, number 9, 10 and 11, due to these three equations, let me fix this equation and let me split whether the splitting is there. Let me split it view. Let me split it. Okay, hopefully this would be helpful to you. And now over here you see we got this result. And over here AP into HQ plus G becomes is equal to 0. So this term would be equal to 0. Therefore, no X related term would be present in this equation. Okay. Next, that's why in this last line no X related term is there. Next, this y related term or the coefficient of y would be is equal to 0 because of the fact that HP plus BQ plus K is equal to 0. So due to this second result, we have the result that y related term would also be vanished. And what is this? What is this? This expression a p square plus this twice h pq plus bq square. Let me write it over here. You see, over here I am writing the expression that a p square plus twice h pq plus b q square plus twice g p plus twice f q plus c. This expression, you see, try to observe it very carefully. You see this expression can be written as A into this first equation, okay, plus, not A, sorry, not A, P into first equation plus Q into this second equation plus this third equation. Got it? You can check, at least over here you see A into P multiplied by P, so AP square would arise. Then P Q, sorry, P Q H, over here Q P H, these two together will construct this twice H P Q. Okay, next this expression P G and this GP, they would construct twice GP. And what is BQ square? BQ square would come from this BQ multiplied by Q. And over here, what is twice FG? Twice FG means this, we have FG over here, and not twice FG, twice FQ. We have FQ over here, and this F into Q would together construct twice FQ, and one more C is there. So in this way, we can decompose the final last term, and finally this expression becomes is equal to 0, this expression becomes is equal to 0, so only we will have this third expression, and that is actually is equal to 0 because of this third term as well. Got it? That's why we can say that in this equation this term would be 0, that means no x would be present, no y would be present, and similarly no constant term would be present. That means we actually have a purely second degree homogeneous equation involving x and y. Got it? So we ultimately have this relation, and we know that a purely second degree equation involving x and y always represents a pair of straight line. It does not represent any other curve at all. Got it? So that's why we can conclude that this equation number 13 actually comes from equation number 1 by different geometric transformation, nothing else. Okay, so this equation number 1 and equation number 13, they would represent same kind of curve, same curve. Okay, and we can now say that as because it is a purely second degree homogeneous equation involving two variables capital X and capital Y, therefore it always represents a pair of straight line. That means equation number 1 always represents a pair of straight line. Therefore you can say that delta is equal to 0 is the sufficient condition to prove the fact that equation number 1 always represents a pair of straight line. Okay, and this is a standard theorem that is actually that can be selected as a standard question in your exam. So that's why out of all the different deductions, I proved the entire deduction for you. Hopefully this would be helpful for your examination purpose. Okay, and there is a corollary that a necessary and sufficient condition that this type of equation represents a pair of straight line represents a pair of real straight line. Okay, sometimes the question comes in this manner, represents a pair of real straight line. Then what is real? Then in that case you will further need to compute one or two more step after equation number 13. How to show that this is a real straight line? The condition is that I told you that h square minus ab is greater than is equal to 0, related to the homogeneous equation of second degree. But over here this is not homogeneous. This is the equation number 1 actually, the purely general equation of second degree. So afterwards what you need to do, we need to further compute this type of steps that I discussed in our previous class, that we are dividing the equation number 13 by this is the equation number 13. We are dividing this equation number 13 by x square or by y square, whatever you feel comfortable. Yeah, by x square. That is actually some printing mistake is there. We have to some printing mistake is there. We have to divide it by x square and y by x. Yeah, so it should be a into y by x twice h into y by x, a plus twice h into y by x plus b into y by x whole square. So some printing mistake is there, so be very careful about these printing mistakes, because I am a human, not a machine. Sometimes I make also mistakes. Anyway, so ultimately it would be written in this form: y by x is equal to this kind of expression, and therefore we will have y by x is equal to this kind of expression. So the for positive sign we will have one value of m, for negative sign we will have another value of m, and these two m would be real when h square minus ab is greater than or is equal to 0. Okay, so that is the condition I wanted to discuss, and that is the result I wanted to discuss over here. Now, do you have any question from this part, from the entire proof? কারো কোনো question আছে? হ্যালো,
স্যার আরেক বললে একটু সুবিধা হতো।
কোন জায়গাটায় বলো, কোন জায়গাটায়?
a plus 2 h x by y এই পার্টটা।
ওইটা অ্যাকচুয়ালি আমার প্রিন্টিং মিস্টেক হয়েছে, ওটাকে টোটাল ইকুয়েশন নাম্বার 13 কে আমরা এক্স এক্স স্কোয়ার দিয়ে ডিভাইড করব, তো আমি এখানে ভুল করে ওয়াই স্কোয়ার দিয়ে ডিভাইড করে দিয়েছি। তো সেটুকুই আমার এখানে মিস্টেক হয়েছে। ইট শুড বি রিটেন ইন ইট শুড বি ডিভাইডেড বাই এক্স স্কোয়ার, সেই জন্য লাস্টে দেখো আমি ওয়াই বাই এক্স লিখেছি, আর এখানে ভুল করে এক্স বাই ওয়াই লিখে ফেলেছি ফার্স্ট লাইনটাতে। তো সেটাই আমার
ঠিক
মিস্টেক।
আছে,
ওকে,
ঠিক আছে স্যার।
আর এনি আদার কোয়েশ্চেন? এবার now we need to discuss these examples, but before discussion, actually these examples would be discussed in the next and subsequent classes, but before discussion I need to show you something related to this kind of examples, because that would be important for you. First of all, you see that this point of intersection p comma q or alpha comma beta, whatever you write, this point of intersection will be represented by three equations, and these are the three equations: equation number 4, equation number 5, and equation number 7. Try to remember these three equations. You can consider any two arbitrary equations and find the expression of alpha and beta. Okay, what we mostly do is that we generally consider these first two equations and we compute the expressions of alpha and beta. Let me see whether I have any ready-made computation or not. No such ready-made computation is there. No such ready-made computation is there. Anyway, so let me show you over here. If we now try to compute the expressions of alpha and beta, then we can consider these two equations and we can use cross multiplication. Then what we have, alpha, maybe something that is over here, we shall have beta. Oh, not alpha beta, we are writing in terms of p and q. Okay, no problem. So p, q, and maybe some constant term is there, some 1. Now what you need to do, we need to compute the denominators portion. So in the denominator of p we have hf minus bg, hf minus bg, then hg minus af, hg minus af, and over here we shall have ab minus h square minus h square. So from this result we can compute the expression of p and expression of q. So what is p? P becomes is equal to this hf minus bg divided by ab minus h square. So of course over here ab minus h square should not be equal to 0. Hmm. Um, and what is q? Q should be is equal to this kind of expression ag minus af divided by uh, ag minus af divided by ab minus s. So we can say that these two expressions, these are the coordinates of the point of intersection of the straight lines. Okay, generally I don't remember this expression because this expression has been derived from this first two equation. A similar equivalent expression can also be derived from second and third equation and from first and third equation. So I always remember these three equations, and whenever required I deduce the expressions of these point of points of intersection of the straight lines. Got it? So try to remember this technique. This is the first observation. And secondly, what I am trying to say is that I am trying to modify this equation in this fashion. Let me remove this equation better. Let me remove this picture. Hmm. And over here, clean area kothay? Clean area. Yeah, this area is clean, a bit clean. Let me draw another similar picture in very simple fashion. Hmm. Suppose these are the coordinate axes. These are the coordinate axes, and now we suppose that we have a homogeneous equation of second degree that is actually represents a pair of straight line passing through origin, and we are trying to draw parallel straight lines. Remember, parallel straight lines over here. Okay, I am trying to show you a result, and that result will be proved in subsequent chapters. I'm just trying to show you a result for the time being so that you can go through the problems. তোমরা যদি প্রবলেম গুলো করতে পারো, সলভ করতে পারো, জাস্ট তার জন্য একটা রেজাল্ট দেখাতে যাচ্ছি। What is the result? The result says that if let me move this one. If this equation, say, let me call it, let me write it, this is the equation number 1, this is rather 1a. This is 1a and this is 1b. Okay, and this is suppose 2a and 2b. That means we can say that 1 is parallel to 2. 1a is parallel to 2a and 1b is parallel to 2b. Okay, and now suppose the equation represented by this pair of straight line passing through origin, suppose the equation becomes a x square plus twice g x y twice g, not g, twice h x y, plus b y square plus twice gx plus twice fy plus c is equal to 0. Suppose this is the suppose this is the equation that is a purely second degree equation representing the equation representing the straight lines 1a and 1b. Okay, then we can prove that if we add this kind of term, then this second equation would represent, this equation number 2 would represent parallel straight lines not passing through the origin. Okay, that means the straight lines represented by equation number 1 and the straight lines represented by equation number 2 would be parallel to each other. Only difference is that the second pair of straight line would not pass through the origin, and we already computed the expression of alpha and beta. We already computed that if this point of intersection becomes is equal to alpha comma beta, okay, in that case we have three equations, that a alpha plus b beta plus a h g is equal to 0. Then we have the second equation, h alpha b beta, h alpha b beta plus f is equal to 0, and g alpha plus f beta plus c is equal to 0. We have three equations, okay, and if we solve these three equations we can compute the expressions of alpha and beta. I am not going to compute the expression of alpha and beta again. What I am trying to say is that we can compute the expression of alpha and beta. That means alpha and beta would be ultimately two known quantities, and as because we know the this coordinates of alpha and beta, we can compute this straight line. Hopefully this is visible to you all. We can compute this straight line. That would be a diagonal straight line of this parallelogram, okay. And what would be the diagonal equation of the diagonal? The equation of the diagonal would be this one, equation number 2 minus equation number 1. 2 minus 1, okay, equation number 2 minus equation number 1 gives the diagonal passing through the origin, okay. 2 minus 1, that is actually the equation, this one, gx plus fy plus c is equal to 0. We can all prove this result, that this equation is the equation of the diagonal. Sorry, I made a mistake, not this equation. I made a mistake. Sorry. That is not the equation of this diagonal. That would be the equation of this another diagonal. We can prove all these results. That would be the equation of this second diagonal. Okay, I am very sorry. Then what would be the equation of this first diagonal? You see, what would be the equation of this first diagonal? That gives the equation of give the diagonal not passing through the origin. And what would be the equation of the first diagonal passing through the origin? The equation would be, you see, this is the point alpha comma beta, and it is passing through the point 0 comma 0. So we have a straight line passing through the point 0 comma 0 and the point alpha comma beta. So how to compute the equation of that straight line? We know that x minus x1, we have a formula, x minus x1 divided by x1 minus x2. What is x2? X2 is equal to alpha over here, and that is equal to y minus y1, that is divided by y1 minus y2. y2 means beta. So this would give us the equation that y is equal to beta divided by alpha into x. If you compute it, is it clear to you, this kind of expression? এটা কি তোমাদের কাছে clear? The formula of the straight line passing through two points alpha beta and 0 0. This would be the equation of that straight line. So y is equal to beta by alpha into x. So this is the last result that I was trying to discuss. This is the diagonal passing through the origin. And that is the last result I wanted to discuss, that this is the diagonal passing through the origin, that means the equation of this diagonal, that is by yellow line, and the remaining diagonal that is not passing through the origin, that is by pink line, that would be the equation of this result. So that's all for today. And in the next some subsequent classes we will have to discuss few examples, and for those examples we require these two results. That's why I discussed them without proving this result. We shall prove all this result in the subsequent classes, but for the next immediate class we need this result. Okay, so that's all for today, and thank you for being patient with me.